we're going to talk about sequence and series. So to write the terms of a sequence from the nth term, a function whose domain is a set of first n positive integers is known as a finite sequence. A function whose domain is a set of positive integers is an infinite sequence. The terms of the sequence are denoted by a letter A with a subscript. So, for example, A10 would be the 10th term in the sequence. Write the first 4 terms of the sequence defined by the nth term. So, notice we're given a general formula. We want to write the first 4. So, we always want to start with n equals 1. So, we're going to do n equals 1, then plug in n equals 2, n equals 3, n equals 4. Which means that a1 is equal to 1 squared plus 5. a2 is equal to 2 squared plus 5. a3 is equal to 3 squared plus 5. And a4 is equal to 4 squared plus 5. And we stop at 4 because it asks us for the first 4 terms. 1 plus 5 is 6. 2 squared is 4 plus 5 is 9. 3 squared is 9 plus 5 is 14. 16 plus 5 is 21. And so your list would be 6, 9, 14, 21. First 4 terms. Okay, now notice number 2 has a fraction with a negative sign inside the parentheses. So be careful. A1 is 3, parentheses, negative 1/3 to the 1 power. A2 is 3, negative 1/3 to the 2nd power. A3 is 3 times negative 1/3 to the 3rd power. A4 is 3 times negative 1/3 to the 4th power. When the negative sign is inside, and with n being a power, we're going to get what's called an alternating sequence. So A1 is equal to 3 times negative 1/3. That's negative 1. A2 is equal to 1/9, positive 1/9 times 3. So that's 1/3. A3 is equal to negative 1 over 27 times 3. Becomes negative 1 over 9. And A4 is equal to 1 over 81. 3 times 1 over 81. That's 1 over 27. So this is what our answers would look like. Notice the signs alternate. And you study a little bit more with alternating series when you get to calculus. So what would our answer look like? So our answer is negative 1, positive 1/3, negative 1/9, and 1 over 27. There we go. Okay, page 2. We also want to look at what are called factorials. So the definition of n factorial is a multiplication. You say n times n minus 1 times n minus 2 all the way down to 1. So this is n factorial. This is used in combinations and permutations. And you'll see it again when you take probability and statistics. So 5 factorial means 5 times 4 times 3 times 2 times 1. 20 times 6 is 120. Now on your graphing calculator, there's a factorial button. You can do the number 5, go to math, arrow over to PROB. Okay, so it's 5, math, arrow to PROB, arrow down to number 4 as the exclamation point. And we hit enter, and we hit enter, and we get 120. Okay, so you could use your calculator. Now here, you can stop the factorial anywhere you need to. So I'm going to count from 6 times 5, we could put an exclamation point, times 4 factorial. So why did I stop here? Because there's a 4 factorial in the denominator, and these divide. So 6 times 5 is 30. Again, we can type in our graphing calculator, 6, math, exclamation point, divided by 4, math, exclamation point, and we get 30. Okay, 9 factorial over 4 factorial times 5 factorial. You're going to count down to the largest number in the denominator, to 5 factorial. 9 times 8 times 7 times 6 times 5 factorial. So I'm going to keep that 5 factorial. Those will divide out. And then 4 times 3 times 2 times 1. And at this point, what you could do is we could simplify it by saying 3 times 2 is 6, okay? So I'm going to divide the 6's. And then 4 goes into 8 twice. 9 times 2 is 18, giving us 126. Again, if you want to confirm it on the calculator, 9 factorial. Now, you have to be careful here. If you don't use the fraction bar, you have to have the 4 factorial and the 5 factorial in parentheses. And we confirmed to 126. Okay, number 7 is a little harder. N factorial is n minus 1. So if I look at the denominator, it stops here. So again, I'm going to divide like terms. That's a 1. And you're left with n. All right, now we're going to look at a summation. A sum is addition. We're going to take a list of numbers, which is your sequence. We'll add them up. That's called a sum. So you have an infinite series that goes on and on forever. And you can only find a partial sum unless we have a geometric that converges, which we'll talk about that in another class. So let's look at number 8. Write the terms for each series and find the sum. So a series indicates addition. So you're going to start with 1. Here's your starting number. 3 times 1 minus 8. Let me alternate colors here. Okay. So we can see our terms. That's your first term. Plus 3 times 2 minus 8. So you plug in 2 for k. Plus, then we go to 3 times 3 minus 8. That's your third term. And you go all the way to 3. So you start at 1, you stop at 3. So this is equal to, let's do this last one here. 9 minus 8 is 1. 6 minus 2 is negative 2. And then 3 minus 8 is a negative 5. So negative 5 minus 2 is negative 7. Plus 1 is a negative 6, final answer. If you have the TI-84, the alpha window, you have a summation. And I always use X. I just think it's a little bit easier. So X is 1 on the bottom. Your top is 3. Now there's parentheses. You have to keep these. So I have to start with the new parentheses, 3x minus 8. Just make sure your variable matches. And I get negative 6. Okay, this one, 9's a little tricky. You go from 3 to 5. See the 3 down here? So I'm going to do negative 1. And I'm going to do 3 minus 1 times 3 times 3. Now I go to 4. Okay, not yet. We're going to do negative 1 to the, we're going to put in 4. And that was a plus sign here. So it was 3 plus 1. So we're going to do 4 plus 1 times 3 times 4. Then plus negative 1 to the 3, 4, then 5 plus 1 times 3 times 5. So negative 1 to 4 is, that's even, so you get 9. Negative 1, 4 plus 1 is 5, so that's going to be odd, so that's a negative 12. Plus 5 plus 1 is 6, negative 1 to the 6 is a positive 15. So you have 15 minus 12 is 3, plus 9 is 12. Now, we can also write the sum in summation notation. So first thing you want to count, there are 1, 2, 3, 4, 5 terms. So we're going to go k equals 1, or we could use n, to 5. Notice the denominator is a 5 regardless. Now, here's your pattern, 2, 4, 8, 16, 32. If you look at your patterns, it's not even, but it's 2 to the n. So this is 2 to the k, because we're using k. So 2 to the 1 over 5. So we have our 5 in the denominator. So that's 2. 2 squared is 4. 2 to the 3 is 8. So we can check ourselves. Again, this one's a little tricky. This is 2 to the 1, 2 to the 2, 2 to the 3. 1 is 2 to the 0. This is 2 to the negative 1. Again, I want to start with, and this time let's use an n, because you can use n or k. It just depends. Count 1, 2, 3, 4, 5 again. So these are definitely powers of 2, but what's tricky is how do you get to your answer? Well, the last term, you want your n value to be 3. So the fifth term, when we plug it in, we want to get 3. So if you notice, n minus 2 is going to give it to you. 5 minus, here, if we do 5 minus 2, we get 3. If I did 5 minus 3, I'd get 2, and so that would be the number I need. Because if we do 2 to the n minus 2, so let's check it. Okay, what if I'm not convinced that's correct? So if we go ahead, we do 2 to the 1 minus 2, 2 to the 2 minus 2, 2 to the 3 minus 2, 2 to the 4 minus 2, 2 to the 5 minus 2. So if I double check that, 2, that's 2 to the negative 1, plus 2 to the 0, plus 2 to the 1, plus 2 to the 2, plus 2 to the 3. Which if I check, 2 to the negative 1 is 1/2. That checks it. 2 to the 0 is 1. 2, 4, 8. And I am correct. So the answer I'm looking for are the actual summation notations. So we're going the other way. If I give you a written out series, can you write it in summation notation? So I hope that you enjoyed this lesson and have a great day.